Question number 1. The area of the shaded part face is 49 centimeters square. What is the volume of the solid? In this case, we can just have the volume to be the shaded face times the length. In this case, over pretty straightforward. So this would then be equal to 49 times 9, and this will be equal to 441 centimeter cube. Right, there you go. Question 3. A triangle is formed by bending a piece of wire. What is the length of the piece of wire? Express your answer in the terms of x in the simplest form. So to get the parameter or the length of wire, basically everything, right? Bracket 2x plus 10 plus 5x minus 3 plus 3x. So then this will be 2x plus 10 plus 5x minus 3 plus 3x. And this will be a total of 2, 5, 3, 10x plus 10 minus 3. That will be equal to 7. And the total will be 10x plus 7. If this is an equation, you need to put brackets centimeter. Question number 4. A fruit seller stored oranges in crates A and B. Crate A contained twice as many oranges as crate B. In crate A, half of the oranges were ripe. In crate B, 5/6 of the oranges were ripe. What fractions of all the oranges were ripe? Okay, so from the statement over here, it says that crate A contained twice as many crates as crate B. So we can convert this into units. So crate A then be equal to 2 units. Crate B will then be equal to 1 unit. So the next thing is, in crate A, half of the oranges ripe. So that means crate A, or ripe in this case, will be half, okay, of 2 units, or of just, which means this is half times 2 units. This will become 1 unit. In the next statement, it says in crate B, 5/6 of the oranges were ripe as well. So that means crate B ripe oranges would then be equal to 5/6 times, so crate B is 1 unit, okay, then this will be equal to 5/6 units. Now it says here, what are the fraction of all of the oranges that were ripe? So this means we need to get the total ripe oranges out of total oranges. So in this case, we need to find the total oranges. So the total oranges is basically 2 units and 1 unit. So that means it's 2 units plus 1 unit. This will give us 3 units. And then total oranges that are ripe, this case, then be equal to crate A ripe plus crate B ripe. And this will then be equal to 1 unit because crate A ripe is 1 unit. And for crate B, it is 5/6 unit. So we see over here 5/6, and this will be equal to 5/6 units. Let's make it into a mixed fraction or mixed number. So this will then be equal to 11/6. So total ripe oranges will be equal to 11/6. Okay, out of, so you divide, and then you have your total oranges, which is 3 in this case. So what we can do is we can just do normal fraction division. We have a fraction divided by a whole number, so divide will be times, and you flip 3 to 1/3, and this will become 11 out of, there you go. So that's the answer, 11 out of. Question number 5. May had 18 more stickers than Aisha at first. After May gave some stickers to Aisha, she had 24 fewer stickers than Aisha. How many stickers did May give to Aisha? Okay, so I draw a model over here. So at first, May had 18 more stickers than Aisha. This case over here. Then the thing is that May gave Aisha some stickers. So if you were to, for example, have 18, that means Aisha has 18 more, right? So May gave Aisha 18. Makes sense? Now the thing is that you might be thinking, if you want to get 24, how much did May actually have to give? So in this case, if you say this is 6, right? If you say, oh yeah, May actually gave 6 more. So if you were to say, okay, May gave 6 more, okay, we can do that. So imagine this is 6, right? For this, let me color it in blue. So that means an additional 6 is given to Aisha. That's what we see over here. So what's the difference then? So you might be thinking, oh, the difference should be, in this case, 24, right? However, the thing is that it is not 24 because we have an additional 6 over here. So actually, the difference is not 24, it's actually 30. So you see over here. So then how do we have this statement to be true, where the difference is 24? So instead of 6, that means this is 6 as well, right? That means we need to get it to 24. We actually have to divide it by 3. So now you see that May actually didn't give 24. she actually gave 21. Therefore, the answer to this is that instead of giving 24, she actually gave 21 stickers, as what we see over here. Question 7, Part A. Figure X below shows a square tile ABCD. It is made up of a triangle BCD, a quarter of circle AFE, and a shaded part BDEF, and AF equal to FB. The area of triangle BCD is 32 centimeters square. What is the radius of the quarter circle AFE? So we know that BCD that's highlighted in red is 32 centimeter square. So this is basically half a square, which means that this over here, if we were to rotate it, okay, will look something like this. It's the same. And that means we have the height and we have the base, right? So in this, pretty straightforward. Actually, the easier way is, since BCD is half of the square ABCD, that means BCD equal to half of ABCD square. That means the 2 out of 2, or the full square of ABCD, it's basically 2 times 32. This will give us 64 centimeters square. Okay, side times side is equal to square ABCD area. So that means the side of the square side is equal to square root of square ABCD area, which in this case is square root of 64, and this will be 8 centimeters. So the thing is that the radius AFE, which is basically is AE over here. So radius of quarter circle is basically the same as AF and the same as AE. So the thing is that since AF is equal to FB, because they are identical, so that means AF is equal to 8 divided by 2. This will give us 4 centimeters. Since we know AF, that means radius of quarter circle will then be equal to 4 centimeters. Question 7, part B. Figure Y is made out of 4 such square tiles as shown in figure X. Find the total shaded area in figure Y. So to find the total shaded area in figure Y, so I will say total shaded area is basically the shaded square minus the unshaded center circle. So we need to find the shaded square in red. So shaded square, pretty straightforward. Basically 4 times 2. This will give us 128 centimeters square. Then we need to find the unshaded center circle, which in this case is pi times radius. And we know pi, which is 3.14, times radius is 4 times 4. And this will give us 50.24. So now we can find out the total shaded area. So total shaded area is basically shaded square, which is 128 minus 50.24, and this will give us 77.76 centimeter square. There you go. Question 8. Alice always spends 70% of her salary. Her salary for December was 40% more than that for November. As a result, she spent $560 more in December than in November. How much was her salary in December? So in this case, for the salary in December, or let's say, let 100 units be salary for November. Okay, because her salary for December was 40% more than that for November. Means the salary for December is, in terms of percentage, is equal to 100 plus 40%, which is 140%. So that means the salary December in units over here will then be equal to 100 units times 140%. This will give us 140 units. So the thing is that we also know as a result, she spent $560 more than December than in November. Okay, so that means spent December minus spent in November is equal to $560. So what did we spend in November? Okay, which is basically in this case 70% of 100 units November. This will be 70, and spent on December is basically 70% times 140 units, which would then be equal to 98 units. So that means spent December minus spent November, okay, would then be equal to 98 minus 70, and this will give us 28 units. Since the spent December minus spent November is 560, so that means 28 units is equal to $560 units. So we need to know how much was her salary in December. So December over here, her salary, if we scroll all the way up, is 140 units. So that means 140 units is equal to 560 divided by 28 times 140. This will be equal to $2800. What you see over here. Okay, there you go. So that's the answer. Question 9, part A. The line graph shows the number of visitors who took the tram in the zoo from Monday to Friday in a particular week. On which day was the tram service in the zoo closed for maintenance? I think it's pretty straightforward. When it says closed for maintenance, that means no visitor. Therefore, the day when there is no visitors, equal to Tuesday. Okay, there you go. Pretty straightforward. Question 9, part B. The line graph shows the number of visitors who took the tram in a zoo from Monday to Friday in a particular week. Find the percentage increase in the number of visitors who took the tram from Thursday to Friday. Round your answer to the closest percentage. First thing is, when you read a line graph, we need to know how many gaps are there before the first number that's not 0. So 1, 2, 3, 4, and 5. So 5 gaps equal to 100. So 1 gap equal to 100 divided by 5. And this will be 20. So we want to know Thursday and Friday. So let's go to Thursday over here. I'll mark it down in red. So Thursday is just one space below 20. That means Thursday go to 180 or 20 minus or 200 minus 20, 180. What about Friday? So Friday in blue, Friday has a sharp increase, and this will give us 400 plus 1 gap. So 400 plus 20, 420. So percentage increase in the number of visitors who took the tram from Thursday to Friday is basically visitor increase from Thursday to Friday is 420 minus 180. This will give us 240. So to get a percentage increase, we need to get a visitors increase from Thursday to Friday and then divide it by Thursday and times 100%. So visitor increase is 240. Okay, and then we divide it by Thursday, which is 180 times 100%. And this will give us 1.33333 dot dot dot. That we need to round it to the closest percentage, which means it's 133%. There you go. Question 10, part A. Winnie and Sophie were paid a total of 3,620 for a job. Winnie was paid 1,960 more than Sophie. How much was Winnie paid for the job? Okay, so Winnie was paid 1,960 more than Sophie. And then we know that in total, they are paid 3,620. So how much was Winnie paid for the job? So in a sense, we have 1 unit for both Winnie and Sophie. So that means 1 unit over here will then be 3,620 minus 1,960, and then we divide it by 2. This will be equal to $830. So Winnie is equal to 1 unit plus 1,960 equal to 830 plus 1,960, and this will be equal to $2,790. Okay, there you go. Question 10, part B. Winnie and Sophie were paid a total of 3,620 for a job. Winnie was paid 1,960 more than Sophie. Winnie and Sophie were paid based on the number of days they worked. Winnie worked 3 times as many days as Sophie. Winnie was paid $5 more than Sophie per day. How many days did Sophie work? All right, so we know that Sophie is $830. And from here, Winnie worked 3 times as many days as Sophie. Okay, so Winnie worked 3 times as many days as Sophie. So that means Winnie total without the $5 more would then be equal to 830. Or in this sense, Winnie total is basically Sophie times 3 plus extra pay. So the extra pay is from the sentence Winnie was paid $5 more than Sophie. So in this case, we know Winnie's total, right? So Winnie's total is $2,790, and Sophie will be 830, and then times 3, and then plus extra pay, right? It's not extra pay, but extra pay lah. Okay, so in this 830 times 3, this would then be equal to $2,490. So from here, we actually can get the extra pay. It's basically 2,790 minus 2,490, and this will be equal to $300. So extra pay that Winnie give. So that means if Winnie paid $5 more than Sophie per day, that means in 1 day she was paid dollars. So in this sense, so Winnie received or was paid $300 more than Sophie, and Winnie was paid $5 more than Sophie per day. That means total days Winnie work will then be equal to 300 divided by 5 is equal to 60 days. And then from here, Winnie worked 3 times as many days as Sophie. So Winnie is equal to 3 times of Sophie in terms of days. So Sophie then be Winnie divided by 3. Since we know Winnie worked 60 days, that means 60 divided by 3, this will give us 20. So therefore, Sophie worked for 20 days in total. Question 11, part A. At first, 1/5 of the rectangular container was filled with water. More water was collected into the container from a leaking tap for 30 minutes. The line graph shows the volume of water in the tank over 30 minutes. How much water flowed into the container in 1 minute? Okay, so to calculate this, we know that the total time is 30 minutes. And at the same time, we want to know what is the starting volume of water. So first thing is we need to look at the gaps, right? You got 1, 2 gaps. So 2 gaps go to 50. 1 gap equal to 50 divided by 2. This will be 25. So the volume at 0 minute would then be equal to, in this case, it is 3 gaps, right? So that means 3 times 25. This will be 75 centimeter cube. Then volume at 30 minutes. This will then be equal to 200 plus 25 equal to 225 centimeter cube. So now from here, you can find the difference is 225 minus 75. This will be 150 centimeter cube. So now we have 150. So what's the water flowed in 1 minute? Would then be equal to 150 divided by 30. This will give us 5 centimeter per minute. Right, there you go. So question 11, part B. At the end of 30 minutes, what fraction of the container was filled? So we know that at first, 1/5 of the rectangular tank was filled with water. So that means 1/5 is equal to 75. So 1/5 of container is 75 centimeter cube. That means 5 over 5 container would then be equal to 5 times 75. And this will be equal to 375 centimeter cube. So we know that the volume at 30 minutes is 225. So that means the end of 30 minutes, the fraction is equal to 225 divided by 375. If you were to simplify it, this will be 3 over 5, this case over here. So always simplify even if the question didn't ask. So question 11, part C. At the end of 30 minutes, the container was filled with water to a height of 3 centimeters as shown in figure Z. Find the possible pair of length and breadth of the container given that both dimensions are whole numbers greater than 1 centimeters. So we know base area is equal to volume divided by height. So the volume that we know is 225, and then we divide it by 3. This will give us 75 centimeters square. So what is so this one, you just have to guess and check, right? So 1 times, so length and breadth times breadth equal to 75. So 1 times 75 equal to 75. So this one, I would say cannot, because question say greater than 1 cm. How about 3 times 25 equal to 75? And this one can as well. What about 5 times 15? This one also can do it. It's either 3 times 25 or 5 times 15 that is applicable. Question 12, part A. In the figure, ABFG is a parallelogram and BCDE is a rhombus. ABC is a straight line. Angle AGF is 67 degrees. BFE is 11 degrees. And CED is 38 degrees. Find the angle FBE. Right, so if you were to just highlight this red part over here, this is what angle we are looking for. Can you guess what is the equation that we need to find angle FBE? So the thing is, for angle FBE, we actually just need to find 2 other angles, which in this case is this angle ABF, which is in purple, and angle EBC, right? So in essence, it's 180 minus angle ABF and minus angle EBE. So let's first find out angle ABF. Angle ABF is part of what shape? So if you guess the shape is ABFG, then you're right. So this is the angle that we're looking at. I mean, the shape that we are looking at was as what we see over here. And this is a parallelogram. Means that parallelogram, one of the properties is that opposite angles are the same. So that means angle ABF is equal to angle AGF. which means this will be equal to 67. Now we know ABF is 67. We want to find EBC. So angle EBC over here, what shape do you think angle EBC is part of? If you were to guess that it is a rhombus, then you're right. EBC is part of a rhombus case. So EBC is equal to angle EDC. So opposite angles in a rhombus are the same. Okay? And in this case, angle EDC is inside the triangle EDC as well. And half of rhombus, basically isosceles triangle. Reason why is because a rhombus has equal sides, obviously over here. Therefore, this makes it to half of the isosceles triangle. So which means the angle EDC over here would then be equal to 180 minus 38 minus 38. This will give us 104 degrees. So which means angle EDC over here would then be equal to 104 degrees. So now we can find FBE, which would then be equal to 180 minus 67 minus 104, give us 9. Go. So the answer is 9. So question 12, part B, we want to find angle DEF, which is in this case this over here. So how do we find it? So we need a couple of angles. The first one is this angle, is angle BED. The other angle that we need to find is this angle over here, which is FEB. So angle EF is basically 360 minus 38 minus angle BED, and then minus angle BEF. Right, so first thing, let's find out angle BEC, which is this green angle over here. So angle BEC is actually equal to angle CED, which is equal to 38 degrees. So why is because half a rhombus creates two identical isosceles triangle, which means this will then be equal to 38. All right. So now we know that. The next thing is we need to find this blue angle over here. So earlier we have calculated this 9 degrees over here. So FBE over here, this little triangle, this little, you see this orange is 9, okay, 9 degrees. So we also know that this other angle is 11. So BEC over here, basically 180. BC? No, BEF. Okay, so BEF over here is this purple little triangle, or blue, sorry, blue triangle. So BF is equal to 180 minus 11 minus 9. This will give us 160 degrees. So therefore, we can find out DEF, which is basically 360 minus 38 minus 38 minus 160. And this will be equal to 124 degrees. Okay, there you go. So that's the answer. 124 degrees. Question 13a. The table shows the prices of entry tickets for theme park. The number of adult tickets sold were 6 times the number of child tickets sold. 4/5 of the adults tickets sold were for adults aged below 65 years old. A total of $9,464 was collected from the sale of tickets. What fraction of the tickets sold were for adults aged 65 years and above? Give your answer in the simplest form. Okay, so from the question itself, the number of adult tickets sold was 6 times the number of child tickets. So that means the total adults over here is 6 and the child is 1. Then from here, 4/5 of the adult tickets sold were adults aged below 65 years old. So 4/5 of the adult. So that means we have to look over here, 4/5, right? Total below 65 years old is actually 4 parts. So below 65, which is this, 4 part. And then above 65 is not 5, it's actually 1 because it says here 4/5. So remainder is 1. 1 part, that means the total adults is 5 parts. Okay, from here, what do you think is the final ratio? So if you were to add another row over here, from 6 units to 5 parts, then we need to find the lowest common multiple, which in this case is 6 times 5, which is 30. That means the child is 1 times 5 is 5. And then for the adult that is above 65, you will times 6 is 6. And then this is 4 times 6 is 24. So give your answer in the simplest form. What is the fraction? Adults tickets sold for adult age 65 plus. Or 65 and above. In this case is adults aged 65 and above out of total. So we need to find the total tickets. So total tickets according to table is 30 plus 5, or adult plus child equal to 30 plus 5 equal to 35. Then the adults age 65 and above, according table equal to 6. So that means adults age 65 and above is 6 out of 35. Right, there you go. Question 13, part B. What was the total number of tickets sold? So we can use the grouping concept. So that means one group has 6 child or children plus adults, that is 24 adults that is below 65 years old, then plus 6 adults that are above 65 years old. Then we can just calculate. So 6 times, so child is 10 plus 24 times 24 plus 6 times 17. And then this will give us, sorry, not 6 children, 5 children. So that will give us $728 for one group, which is the total of how many tickets? 5, 24, 35, right? 35. So now we need to find the number of group, which is equal to, so we know the total, 9464 divided by 728. And this will give us 13 group. So that means total tickets is equal to 13 times. So one group, how many tickets do we have? 35. And this will give us 455 tickets. Okay, there you go. So that's the answer. Question 14a. Ben baked 3 types of muffins for sale. The number of each type of muffins Ben baked is represented by the bar graph below. The bars for the number of chocolate muffins and vanilla muffins have not been drawn. The ratio of the number of chocolate muffins to strawberry muffins to vanilla muffins is 7:5:9. Draw the bars that represents the number of chocolate muffins and vanilla muffins Ben baked in the graph above. Technically, my graph is over here. Okay, so we know that chocolate is to strawberries to vanilla is 7:5:9. So we need to know how many gaps are there in the strawberry. So we will just count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So for strawberry, we have 10 gaps. So which means we need to convert this into 10. So that means we have to just multiply 2 for each. And this will give us 14. 10 is to 18. Therefore, we just need to add the chocolate to 14, which is 1, 2, 3, and 4, which is roughly around here. Chocolate then be like this. And then for vanilla, chocolate, strawberry, vanilla, it will be 18. So we have 14 over here. And then we just add 4 more, which is 1, 2, 4. And this will then be equal to 18, as what we see over here. Okay, there you go. So that's the answer. All right, question 14, part B. Ben sold all his strawberry muffins at $3.20 each. He collected a total of $192 from the sale of the strawberry muffins. How many muffins did he bake altogether? So we want to know the number of strawberry, which is basically 192 divided by 3.20, and this will give us 60. So that means 5 units equal to 60. So we want to know the total in terms of units is equal to 7 plus 5 plus 9, and this will give us 21. So we know the total units 21. So we just write 21 units will be 60 divided by 5 times 21, and this will give us 252. There you go. So that's the answer, 252. Question 15. Part B. In the 1 centimeter square grid below, line CB forms one side of an isosceles triangle, CBE, in which CB is equal to BE. Draw a right angle triangle CEF on a grid such that EF is twice the length of BC. Triangle CEF must not overlap triangle CBE. Label your figure clearly. Alright, so we know that CB is equal to BE. So what does that mean? That means is that this line over here, so we will have to create a right angle triangle. And we need to count how many units in this sense over here. So for this, for the height, it is 3. And for the base, it is 2. So in order for us to get the same length, because we want to create the isosceles triangle CBE, and CB is equal to BE, that means we need to do the same as what we've seen over here. So we need to have the base of 2, and then we need to get the height of 3. So that means the line CB is equal to this part over here. So that means CB, and this will be E. Therefore, this is the triangle. That's what you see over here. Question 16, part A. There were some books on shelf A and shelf B. Emily took out 1/7 of the books from shelf A and placed them onto shelf B. As a result, the ratio of the number of books on shelf A to the number of books on shelf B became 3:5. There were 156 more books on shelf B then shelf A. What's the ratio number of books on shelf A to the number of books of shelf B at first? So this is where we can use the before, change, and after table. So let's create this table over here. So it says here Emily took out, so this is the before, change, after table with the shelf A and shelf B. So Emily took out 1/7 books from shelf A and place them into shelf B. So that means originally we have 7 and then we minus 1, internal transfer to shelf B plus 1. And then from 7, what do you think we are left? 6. So if I were to put this here, okay, then as a result, the ratio number of books for shelf A to shelf B is 3:5. So we're going to add another one here. This 3:5. This after as well. So then therefore, how do we get from 3 to 6? That means for after 6, it is 3 times 2, which is equal to 6. And 3, so that means 5 times 2, which is equal to 10. Since we know this is 10, therefore, shelf B, if we received 1 to get 10 in the end, that means at first he got 9. Or you can put 10 minus 1 is equal to 9. So now, from the question, there were 156 more books on shelf B than shelf A, means the difference is equal to 156. And we know the difference now in terms of units is equal to 10 minus 6, which is 4 units. So that means 4 units is 156. Then we want to know what was the ratio number of books shelf A to shelf B at first. Or this one no need. So it's just 7:9 lah. Okay. So therefore we don't need the difference, but now we know the ratio is 7:9. So that's about it. All right. So for part B, how many books were there on shelf B at first? So we know that the difference in the question is 156. So the difference in units then 10 and 6 over here will then be equal to 156. Therefore, 4 units is 156. Now we know that shelf B in the end is, or at first, is 9 units. So that means 9 units will then be 156 divided by 4 times 9. And this will give us 351. Right, there you go. Question 17, part A. Stall A and Stall B sold the same total number of burgers and sandwiches at a school carnival. Each burger cost $4.50 and each sandwich cost $2. Stall A sold some burgers and 64 sandwiches. Stall B sold some burgers and 96 sandwiches. Which stall collected more money? So the concept over here is that Stall A and Stall B sold the same number of burgers and sandwiches as well. So that means, let's assume both stalls sold 100 total burgers and sandwiches. Why 100? Because stall B sold some burgers and 96 sandwiches. We need a number that is bigger than 6 and a easy number to use to multiply. Okay, so which means from here, stall A sold some burgers and 64 sandwiches. So stall A total is equal to 100. So stall A sandwiches is equal to 100. No, 64. And then stall A burgers is equal to 100 minus 64. And this will give us 36. So total money collected is equal to 36 times $4.50 plus, so this is the burgers. So sandwiches will be 64 times $2. And that will be a total of $290 for stall A. Total money collected. So now we're going to do for stall B. So stall B over here will be 100. Sandwiches 96, burgers is 4. So if you were to do the stall B money collected, we'll just multiply. So burgers will be 4 times $4.50. Sandwiches will be 96 times $2, and then the total will be 210. Therefore, the difference in money collected will then be equal to 290 minus 210, and this will give us $80. Okay, pretty straightforward. So the thing is that, let's say we have a random number of 138 total for each stall. Do you think the difference is the same? So 138 is a random number. So let's say stall A total is 138. Sandwiches is the same, but then stall A burgers would then be 138 minus 64, which is 74. That means stall A total money collected would then be equal to $461 if you were to calculate. Then if you were to do stall B total, then it's the same, right? Stall B total is always 96 for sandwiches. Total is 138. That means the burgers will be 42. So the total money collected will then be equal to $381. So stall B collected is 380 and then stall A collected is 460. Can you guess what's the difference? So earlier the difference will be 80. Do you think the difference will be 80 the same way? So let's find out. Difference is 460 minus $381, and this will be $80. Okay, so there you go. So you know what's the difference. So the difference is the same. So now we know which store collected more money. So from here, I think it's pretty obvious. Obviously, stall A money more collected, right? All right, question 17, part B. So it says here the total mass of burgers and sandwiches sold at stall A was 8.32 kg. Each burger is 60 grams heavier than each sandwich. What is the total mass? Okay, so similar to what we went through just now, let's say each sandwich is 1 gram. So that means each sandwich is 1 gram and each burger is 61 grams, right? Now, if the total is 100, same thing as what we've done, that means, sandwiches 64, burgers is 36. So if we calculate the total mass of stall A is 2,260 grams. And then stall B as well, we'll do the same as what we've done earlier. We'll calculate the number of sandwiches and burgers. So stall B total mass will then be equal to 340 grams. That's what we see over here. Okay. So now the thing is, the difference in total mass between each stall A and stall B, will just be 2260 minus 340, which is 192 grams or 1.92 kilograms. So I see over here. So the thing is that, do you think the difference in total mass is the same with 138 total burgers and sandwiches? And we can just calculate again. So same thing, if total is 138, then stall A total is 138 minus 64, that the burgers and sandwiches. Then we can get the total mass again, which is equal to 4578. Then stall B, same thing. We will calculate the burgers and sandwiches and the mass as well. And this will give us 2658. Then if we calculate the difference in total mass, it will be 4578 minus 2658. And this will give us 1920 grams or 1.92 kilograms. The same as if it were to be 100 total. So now the thing is that, since the difference is the same, if stall A is equal to 8.32 kilograms, that means stall B is equal to 8.32 minus 1.92. And this will give us 6.4 kilograms. So there you go. So no matter what, the difference will always be the same. You can always assume each sandwich to be, I would say, the smallest number, so you can in a way calculate. So that's about it. All right, if you like this video, give it a thumbs up. If you want more of this kind of video, subscribe down below and comment down what are the things you want me to show you next. In the next one, bye bye.